In the parallelogram ABCD, E and F are the midpoints of AB and CD respectively. Show that the line segment AF and EC trisect the diagonal. So here we have the diagonal BD, and we must show that these two, that AF and EC trisect it. Means the question is to show PD equal to PQ equal to BQ. So this part of the sum is given, all this you write is in given, and this part of the sum is to prove. The sum is done in three parts. Let's just get on to part 1. Here we know AB is equal to DQ, opposite sides of parallelogram. So we write AB equal to DC, reason opposite sides of parallelogram. If AB equal to DC, we can say half AB equal to half DC. Now, what is half AB? It's given to us that E is the midpoint of AB. That means half AB will be equal to AE. Half AB will be this AE. And on the other side, we have F is the midpoint of DC. Therefore, we can say half DC equal to FC. Yeah, this FC. The reason here for this, E, F are midpoints of AB and DC. So let us now continue. So first we said half AB equal to half DC. We are continuing from here, from this point. So for half AB, I will write AE, and half DC, I will write FC. I am using this information from these two. So I have AE is equal to FC, and AE is also parallel to FC. AE is parallel to FC. If one pair of sides is parallel as well as equal, I have a parallelogram. So now here is a parallelogram, and the parallelogram is AFEC. So AFEC is a parallelogram. AFEC is parallelogram. The reason? One pair of opposite sides are parallel and equal. Therefore, AECF is a parallelogram. This is step 1. So if it's a parallelogram, we can now write FA is parallel to CE, and we are going to use this later, that these two sides are parallel, the opposite sides of the parallelogram. We are going to use this information later. So I'm going to mark, we already have proved these two are parallel. FA parallel to CE. I'll write that FA parallel to CE, and we have proved this. Now let me take up the triangle DQC. Just focus on the triangle DQC, and I'm going to erase all this because I need to focus only on this triangle. Now in this triangle, you see, can you see a midpoint? F is a midpoint, and here we have a line that is parallel. If we have a midpoint and a parallel line, let me draw this. Suppose here I have a midpoint and I have a line that is parallel. I use converse of midpoint theorem, which says if I produce this line, this point here also will be the midpoint of the other side. So we use that information. So in triangle DQC, we know F is midpoint, which is given midpoint of DC, and PF is parallel to QC. So now I can say by converse of midpoint theorem, I can say this F here, F was given as midpoint, so I don't take this. I can say this P here is also midpoint. So therefore P is midpoint of DQ. This is by converse BPT. Let me go over it again. The red lines were already given parallel, and I took the triangle, this triangle, and in this triangle here was given a midpoint, and I had a parallel line. To make things simple, I don't need all this, so I erase this out. So I've got a midpoint, this is my midpoint, and I got a parallel line. Therefore I can say that here P is also midpoint by converse of midpoint theorem. So P also becomes midpoint. So here these two are equal. So I will write now dP equal to PQ. Now here again I have the two parallel lines. Now we're going to take the other part of the another two triangles, and that triangle will be ABP. Here we take ABP. So we'll erase this out. We don't need this part. It is given to us parallel. We have these parallel, which we already proved earlier. This was a midpoint. E was a midpoint. Therefore I can now say Q also is midpoint by converse of midpoint theorem. So I'll take up triangle BAP, and in triangle BAP it was already given to us that AP parallel to EQ, that we have proved earlier, and E is a midpoint of AB. So here was E is the midpoint, and these two lines are given parallel, EQ parallel to AB, hence the other point at the other end, that is Q, also will be midpoint. Therefore Q is midpoint of BP by converse midpoint theorem. So now I can say these two are equal. So BQ equal to PQ. I'll put this as equation 1 and this is equation 2. If I put both the equations together, I have in the first part I have dP equal to PQ, and now I have PQ equal to BQ. So if I put all of them together, I can say dP equal to PQ equal to BQ. So all these three parts are equal. So we can say AE trisects BD. See, BD is cut into three parts, 1, 2, 3 equal parts. So we can say that AF and EC trisect, cut into three parts, BD, and we have proved. Show that the line joining the midpoints of the opposite sides of a quadrilateral bisect each other. So here we have any quadrilateral. Quadrilateral is a four-sided figure, any four-sided figure. We will write A, B, C, D. And what must we show? Show that the line segment joining the midpoints of the opposite sides. Now, who are the opposite sides? AB and DC. So this two I have to join, these two midpoints. I'm joining here. And the midpoints of the other opposite sides, this and this here. I'm joining this. See, they intersect at O. I have to show the bisect, means I have to show here equal to this and this equal to this. I will mark here as PQRS. So basically I have to show OS equal to OQ. I put it the same color. So I have to show OP equal to OR, and on the other side OS equal to OQ. So they are bisected. And this is a very simple proof. We have already done it. All I'm going to do is I've joined this and I'll show this PQRS is a parallelogram. If PQRS is a parallelogram, suppose this is now a parallelogram, PQRS, let me draw it another way. The way it's given here, we have drawn the PQRS in this manner, right? This is my PQRS. If I show it is a parallelogram, and remember the diagonals of a parallelogram bisect, so this is one diagonal and this is the other diagonal. So if I show PQRS is a parallelogram, automatically these two will be equal and this will be equal to this, and I have shown what I need. So all I need to do in this sum is show PQRS is a parallelogram and the diagonals will bisect, and we have proved. So given ABCD is a quadrilateral, any quadrilateral, and this quadrilateral has got midpoints, so PQRS, so PQRS are midpoints. Let's write that. PQRS are midpoints of AB, BC, CD and AD respectively. Here we need to prove that they bisect, means we need to show, we're going to join this up here like this. Here they intersect at O. We need to show OP equal to OR and OQ equal to OS. This is what we need to prove. So for this we will join AC, construction, join AC. So here first we'll take up the triangle ACD. So we'll just join that, ACD. You have two midpoints, S and R. So when I join SR, SR will be parallel to AC and SR will be half of AC. So this triangle DAC, S and R are midpoints. This is just the same as the first proof. Midpoints of AD and DC. Therefore, you can say SR equal to half AC and SR parallel to AC. Midpoint theorem. Now it's time to take the lower triangle, and the lower triangle is this one. Here again we got two midpoints, P and Q. So when we join PQ, it will be parallel to AC and half of AC. So we'll write that. So in triangle BCA, P and Q are midpoints of AB and BC respectively. Therefore, I can say PQ is parallel to AC and PQ is half of AC. So if we put both these statements together, This is by midpoint theorem. This is statement say 1 and this is statement 2. If I put both these statements together, I will now get SR is equal to PQ and SR is parallel to PQ. Therefore, I have a parallelogram. One pair of opposite sides are parallel and equal. I have a parallelogram and this is my parallelogram. So I say therefore PQRS is a parallelogram. Reason, one pair of opposite sides are parallel as well as equal. So this is one part. Now for the next part, now remember we have shown PQRS is a parallelogram. So here for the last part, PQRS is parallelogram. We have already proved it. So let's join the diagonals of this parallelogram. So who are the diagonals? One diagonal is PQ, PR, and the other diagonal is SQ. So in the parallelogram, the diagonals bisect each other. So I can say now, if I mark this as O, I can say OP equal to OR, and I can also say OS equal to OQ. And the reason, diagonals of a parallelogram bisect each other. Of a parallelogram bisect. So proved. I've already proved. What did I prove? I proved that if I have any quadrilateral, any BCD, any quadrilateral, and if I join their opposite midpoints, one midpoint here and these two midpoints, they bisect each other. Here equal, and on this side this is equal. And how did I show it? Just by showing that this is a parallelogram. I showed this part as a parallelogram. PQRS I showed as a parallelogram, and you know how to do that. ABC is a right angled triangle, right angled at C. So let me mark that here. So this right angled triangle, C is 90. A line through the midpoint M of the hypotenuse. So here M is the midpoint of the hypotenuse, which means I have to write both these equal. Remember, M is midpoint. Parallel to BC. So here is a line that is parallel to BC. So I'm drawing this line here. It is parallel to BC. Intersects AC at D. Show that D is the midpoint. Now if you notice here, we have converse of midpoint. Why? M is a midpoint. Okay, we have midpoint here. And we have this line that is parallel. So that means, let me draw this again here. So like this, we have the line. Here we have a midpoint. And we have a line parallel. If we have a midpoint and a parallel line, we have midpoint theorem. So which means when we produce this, this becomes also midpoint. So in this case, let's mark it again. M was a midpoint. We have a line that is parallel. Now if we produce this line further, we will get another midpoint here. D also will be midpoint. This is by converse of midpoint theorem. This line is parallel to this here. So let's write it out. So in triangle ABC, first we have M is midpoint of AB. So we have a midpoint and we have a parallel line. It was given to us L is parallel to BC. So if we have a midpoint and parallel line, we can say the other point is a midpoint. So therefore D is also midpoint of AC. So if this is one midpoint, here we have another midpoint. D is midpoint of AC, and this is by converse midpoint theorem. midpoint theorem. So we have proved one. Now let's go and prove the second part. For the second part we have 90 and we have these two lines parallel. It's given to us. So by corresponding angles, which are the corresponding angles? C and this will be corresponding, right? So these are 1 and C is corresponding. Now can you say that MD is perpendicular to AC? Here we have MD is 90 perpendicular to AC. For second part, we have L parallel to BC and that is given. We have this angle C, angle ACB equal to angle 1 and reason corresponding. See these two angles, let me mark it again. Here angle 1 equal to angle C, corresponding angles. Therefore angle ACB is also 90, and if ACB is 90, we know that MD is perpendicular to AC. So we have proved the second. Now let's go and prove the third. For the third part, we need to prove CM equal to MA equal to half AB. For that we need to take two triangles. We are going to draw by CBCT. We will take here this triangle and then we take these two triangles and prove that they are congruent. We already have 90, angle 1 is 90, which is equal to also angle 2, these are 90, 90. We have these two equal. We said that D was the midpoint here, therefore AD equal to DC. So by SAS test the triangles are congruent. So we need to write this. So we have triangle ADM and triangle CDM. DA equal to DC. Reason, D is midpoint of AC and that was proved. Then the next was angle 1 equal to angle 2 equal to 90. This was also proved. And then we have DM equal to DM common. So triangle ADM congruent to triangle CDM, and that is by SAS test. So by CPCT I can say CM equal to AM. Now see, this is CM will be equal to AM. Here this is by CPCT because the two triangles are congruent. Now further, CM equal to AM, but for AM I can write half AB. Why half AB? Because I know that M is a midpoint of AB. The reason, M is midpoint of AB. So I have proved.